Hi everyone, this is video 4, and today I'm going to talk a little bit more about functions and also something called control and conditional statements. But before I start into this material, I want to review a little bit of the material we went over from last lecture, specifically the end of last lecture. I know some of this environment diagram stuff can be tricky and kind of confusing, and I know when I was a student in this course, I found this stuff initially confusing, so I definitely want to make sure I go over it well. So let's talk about the execution procedure for defining functions one more time. We basically, every time we create a function, every function has a signature. We have the function name and the formal parameters, and this composes the signature. So we create the function with the appropriate signature in memory, and then we set the body of the function to everything indented after the first line, and then we bind the name of the function to the name is square in this case, and we bind it to the object in memory. Okay? So, from here, every time we call user-defined functions, we create a new local frame, forming a new environment, so that's shown here. And then every time we do that, we have to make sure we bind the formal parameters, which again is right here, to the arguments passed in, and in this case we passed in 5, so we bind x to 5 in the local frame, and then we execute the body of the function in the new environment. In this case, it's just returning the square of it, which is 25. So again, this is a review of calling user-defined functions and defining user-defined functions. And one more thing to review, this is super important that we understand that environments are sequences of frames. Every single time we want to look up a name, it evaluates the value bound to the name in the earliest frame of the current environment. And we'll see examples of this that'll make it clear. I know I promised that last time, but in this video, I will definitely go over an example of this. And every time we want to look up a name in an environment, we look for the name in the local frame. And one thing I wanted to note is that we only do this if the local frame is part of the current environment. It could be the case that the current environment is only the global frame, in which case we only need to look for in the global frame. And the second step otherwise is that we look in the global frame. The first step could be that we look in the global frame if there is no local frame, okay? And this will again be made clear in some examples. So let's look at some examples. Take a moment to think about this function, and I'm just going to go straight through it. So here we have this function. What we're going to do, our favorite function square, we're going to define it first. And then now, what do we have? We have a nested call expression. Remember, think about the expression trees. I'm not going to draw it out for this one, but basically we're going to evaluate the operator and then evaluate the operand. What's the operand? Call expression. And then if you remember, the bottom of the tree is going to be square of 5. So that's going to actually, and remember we build up from the bottom up in our tree. So the first call expression we're going to have is actually the inner expression. So it's going to be square of 5. Okay. So here is our first new frame when we call the function. And now we're going to evaluate the body of the function. So we return x times x. Oh, by the way, don't forget we bound the formal parameter x with the argument 5. So this is pretty standard. And then now we return the value 5. And now earlier, every time we returned the value, the frames exited. But I actually found this really cool option where you can show exited frames instead of hiding exited frames. Okay, and so I think this is more instructive if I show it like this. So let me, that's what I'm going to do. And so after this, what happens? We go back into evaluate this. We evaluate square of 25. Remember, what we returned was 25 here, right? That is returned right here. And then the next call expression, remember we build ourselves back up in the tree, and we call square of 25, and the return value of that is 625. So, which is shown right there. Okay, and then we're done. So, let's analyze this a little more. So this is our final environment, and now, remember, I talked about environments as sequences of frames, and this is our first example where we see multiple environments. And remember, every single environment we've gone over in this so far has only consisted of either a global frame or a global frame and a local frame, okay? So now here's actually, there are 3 environments in this example. One being just a global frame. So the global frame is always by itself going to be an environment. Another environment that we had was when we evaluated square of 5. We had this environment with this one local frame right here and a global frame. So that's our second environment. And then we had another environment where we were evaluating square of 25. And that had this local frame connected to this global frame. Okay? So So this is an example of basically having multiple environments, and this is very important that you understand this because the execution rules for this get a little trickier when we deal with something called higher order functions later on. So I want to make sure that you understand this, and it's so important that I'm going to give you another example to practice. Okay, so make sure, see if you can draw out the environment diagram for this, and see if you can also identify the environments that are going on. Remember, environments are chains of frames, and right now it could either just be the global frame or the local frame followed by a global frame. So let's take a look at this. I'm going to spoil the answer to this. So here we go. So we're going to define a square function. We're going to define a sum of squares functions. And this is stuff you've already seen. Here we have our first call expression. So we're going to make a new frame, sum of squares. And then we're binding the formal parameters 3 and 4 to x and y. Sorry, we're binding the arguments to the formal parameters. The arguments are 3 and 4, and the formal parameters are x and y. My bad. Mixed that up that one time. But yeah, make sure this you understand this is the formal parameters and these are the arguments. Very important. So from here, we now have to evaluate the body of this function. Well, hey, in the body of this function, we have a return expression that is another function call. So we go from left to right, basically. So the first function call we have is square of x. What's x? 3. So square of 3. So we're going to evaluate this, and we're going to get a new frame, square of 3. Okay? And again, the formal parameter was x. The argument we had was we passed in x. Okay, so it's a little confusing here because the formal parameter is x right there, and the argument we pass in is x. And in this case, x evaluates the 3. So it's a little confusing, but not too bad. So, and then here, we return x times x, so that gives us 9. And then from here, we're going to then continue evaluating. So where does 9 return to? 9 returns to right there. And then our next expression is going to be another call expression. So we're going to call square on 4, which is the value that, so we look up y, right? What was the environment that y was in? It's in this environment. So we look here, it's 4, and bam, we have square of 4 as our next frame. And so that returns 16. And then at the end of this, it all goes to 25. So here, the environment diagram was a little more involved. So let's analyze that. We had 4 frames total. But in reality, let's look at the environments. So again, we have an environment with only the global frame. That's like in this scope right now. We also have an environment with the sum squares function, and that's tied to the global frame. So this is, again, environment's chain of local frame with a global frame. So here we have our local frame sum squares, and then it's the global frame. And then, so this environment was while we were evaluating sum squares, and then this environment was when we were evaluating the first call to square of x, which is, so that's our third environment. And then our last environment is the square function where we evaluated square of y, which is 4. So these are all the environments. It's important that you can basically identify these environments given any environment diagram, draw them out. Again, identifying these environments are going to be super important when we look up names. So again, you might have seen this slide before, and this is not a joke. This slide is so important that I put it again. Okay, so again, environments are sequences of frames. Names evaluate to a value bound in the name of the earliest frame of the current environment. So I will show you an example of how this applies. And again, steps for looking up a name's environment: look for the name in the local frame. Again, only if the local frame is part of the current environment, and then we look for the name in the global frame. So now here's our example of looking up names. Okay, so see what happens. Try this. What happens after we execute line 7? So this is a little tricky. I want you to think about it for a little, and I'll spoil the answer in 3, 2, 1. The answer is actually, we're going to get an error. So this is a little bit of a trick question. Sorry about that, but it's also very instructive. So let's look at how the environment diagram works out for this one. So we have this function rectangle area. It takes in 2 arguments. We're going to define that. And then now we have a call expression, make a new frame. We'll bind the formal parameters L and W with the arguments passed in, 4 and 5. And then we're going to make these intermediate variables basically. Honestly, there's really no use for this. We could have just done return L times W, but I did this to confuse you, just so for instructive purposes, of course. And so now we have length as 4 and width is 5, and then we're going to return length times width, and that's 20. Okay, so our area is then going to be bound to 20 in the global frame. So again, we have one environment right now with the global frame, and another environment where we invalidated the rectangle area that's tied with this frame and this frame. So again, identifying environments is super important. So what's our current environment though? Well, our current environment is, well, you're lucky in that they highlighted blue what the current environment is, but really you should be able to identify this because, hey, we finished our rectangle area evaluation. We don't need it anymore, so now we're just in the global frame. So our current environment is the global frame only. So what do we do when we look up a name? So we go right to left. First we have an assignment statement. Width is being bound to new width, and so we evaluate the right. What is width? Well, we have to look at it in the global frame, but hey, there is no width. So what happens is that we get an error that width is not defined, and because of this chain of environment stuff is why this error occurs. So it's important that you understand this. The current environment is only the global frame, and because we look at width in the global frame and there is no width, we get a name error. So make sure you guys understand this. It's okay to go back and go through my explanation one more time.